Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2523, closest prime numbers in the range. This question is based out of math, or you can say number theory, and it is asked in TikTok 3 times. Let's have a look on the problem statement. Here we are given two positive integers left and right, and along with that we have to find two integers num1, num2 such that they are following these three conditions. First condition is num1 and num2 should be between this left and right such that num1 is less than num2, and both the num1 and num2 should be prime numbers. It means they are divisible by 1 or the number itself. Third condition is num2 minus num1 should be minimum. Okay, there might be so many pairs with num1 and num2 from the above two conditions, but we have to choose the minimum one where num2 minus num1, this value is minimum. After finding that specific pair, just return that pair in the form of array num1 comma num2. If you are not able to find any pair, then return -1 and -1. This is our problem statement. Now let's try to understand in a simple manner what is given to us. Two integer value. First one is left, second one is right. Our aim is to find two integer num1 and num2 such that num1 is greater than equal to left, num2 is less than equal to right, and they are between the range. Num2 should be greater than num1. This is the first condition. Okay, it's clear that we should pick the numbers from this range. Second one is both these numbers should be prime numbers, and keeping in mind that this value is minimum. Whatever pair is giving this value minimum, we are just taking that pair in our answer and return answer in the form of array. This much we have to do, and let's try to have a look on the example. What will be the output of this example? Let's say in this case our left value is 10 and the right value is 19. Let's say this is the case. The same one above one, like left is 10, right is 19. First of all, we should be knowing all the prime numbers between this range. If I extract out all the prime numbers between this range, those will look like this: 11, 13, 17, 19. And from these numbers, we have to form pair. Form pair like you have to choose num1 and num2 such that the difference is minimum. If the difference is minimum, you will definitely be choosing adjacent pairs, right? With 11, you have only one option to choose 13. Otherwise, these will definitely be giving you bigger delta. So two adjacent pair I and I plus 1 we have to choose such that their delta is minimum. 11, 13, the delta is 2. 13, 17, delta is 4. 17, 19, delta is 2. So in this case, 11 and 13 is giving me 2 difference, and 17 and 19 is giving me difference of 2. Two pairs are giving me minimum value. In that case, what I have to choose is one with the smallest num1 value. Num1 value is smallest for this pair, 11 and 13. So 11 and 13 will be my answer in this case, right? So now I can easily say that our problem statement is something like finding this list. If we are able to find this list, we can iterate over this list in a linear time, and while iterating I can check all the adjacent pair with the delta. So whatever pair is giving me minimum delta, I'm going to pick that. So my problem statement is now I have left value and right value, and from that left and right I have to pick all the prime numbers. All the prime numbers which are greater than equal to left and less than equal to right. So how you can find that? And then we will be having a list of all the prime numbers, and from that list we can pick the adjacent pairs to check the answer. Now this is my problem statement, finding all the prime number between a range. So for that, if I want to do it a very naive fashion, I can write a loop that will go from left till right. Let's say I'm having I pointer. I pointer is starting with left and going till right. my aim is I have to check whether I is prime or not. Now this is the subproblem, whether a number is prime or not. How do we check? We can by writing a loop from 2 to that num minus 1 2 to I. Let's say I value is 12 in this case. Let's say 11. I is 11. I will be checking by dividing it to all the numbers from 2 to 10, right? Instead of 2 to 10, if you must be aware that we have to go till square root of 11 to check whether this number is a prime or not. See, let me give you a brief idea about that. Why do we check till square root of n? Square root of n, whether the n is prime or not. Is prime function for n. If let's say n is 12, in this case, let's take a perfect square. Let's take 36. If I just try to check what are all the numbers from 2 to 35 which are dividing this number. 2 is dividing this number with 18. 3 is also dividing the number with 12. And 6 is also dividing this number because it is a perfect square of 6. 6 into 6. Correct? From the range between 2 to num minus 1, these are all the numbers which are dividing this number. Right? If we have a look on this number, this is a perfect square. This is square root of 36. Square root of 36 is something which is dividing it completely. If let's say we are having 35, we might not find a square root. But apart from square root, there are two pairs on the right side, two pairs on the right side. If it is divided by 2, if it is divisible by 2, then there must be another number which will be lying right side of the square root. One number on the left side of the square root. This is the left portion and this is the right portion. One number on the left side is corresponding to the one number on the right side. For 3, we have 12. If there was not any number on the left side, there won't be any number on the right side. If 3 was not there, 12 will not be there. Right? In this case, I can say that if there is no number on the left side of the square root of n, then there won't be any number on the right side of the square root of n. And for 36, if I just run a loop from 2 to 35, it will be like order of n. And if I run a loop till square root of 36, it will be order of square root of n, which is significantly lesser than order of n. Now using this, what I am trying to say is that to check whether a number is prime or not, we have to go till square root of n. This is the time that we have to take. So, and in this case, we require all the primes from left to right. So, I equal to left till I less than equal to right, whether it is a prime or not. So, square root of I will be the range. And let's say these are n in number. So, it will be n. So, now in this case, we are going from left to right. And for every ith number, we are checking whether it is a prime or not. To check whether it is a prime or not, it will be square root of I. Square root of I for every I going from left to right. So in this case, let's say if it is from 10 to 19, it will be square root of 10 plus square root of 11 plus square root of 12 plus till square root of 19. In other words, you can say the time complexity is n into square root of n. So this is our first approach. And whatever is the prime number, we can add it in a list. And from that list, you just find the adjacent pair which are giving the minimum value. Right? So this was our first approach, which we can do in a square root of n time for every pair, for every number. So in total around n into square root of n. The second good method for finding prime numbers within a range is Sieve of Eratosthenes. Now why we are looking at this approach? If that approach is going to give me answer in the square root of n, that will also work. But yeah, this is another way of approaching or finding all the numbers from a range from 1 to n, finding all the prime number within this range. And this algorithm will be able to give us that list in order of n into log of n time, right? And this log of n is slightly minute better than this one. Now let me give you what is the idea behind this Sieve of Eratosthenes. Let's say my number is 12. If my number is 12, and what I do is I usually take a hash, or you can say take an array where index is mapped with a number. Index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this is the array. This array can be of Boolean type. It's totally up to you. Let's say it is a Boolean, and let's say it is initialized with true. Firstly, all the numbers are prime. Later on we'll do some processing and make it correct. Okay, let's say we have taken an array of size 12 and all the array is initialized with true. Now you already know 0 and 1 we do not consider, right? Make it false. 0 and 1 just make it false. And starting from 2, whatever true we are getting, we are going to capture in the list. See, now I am at 2. Whether it is a prime or not, it is a prime. Yes, this is a prime. Capture it, and now make every multiple of 2 false, because 2 is definitely going to divide that item. 2 is going to divide 4, so make it false. 6, make it false. 8, make it false. 10, make it false. 11, make it false. Right? All of the other ones are false. Now this is my iteration pointer. Iteration pointer will move to the next one. Next one is 3. 3 is also prime. Yes, it is true. This is a prime. Capture it and make all of the multiples of 3 false. 6 is the one, it's already false. 9, just make it false, and 12, make it false. Yeah. Now I am coming to 4. 4 is already false, just move ahead. Coming to 5. 5 is true, 5 is a prime. Just capture 5 and make all the multiples false. Second multiple is 5 plus 5, which is 10. 10 is already false. And then other one is going out of range. Ignore that. 6 is already false. 7 is a prime. Capture it and make all the multiples. 7 into 2, 14. That is out of the range. But if a number is within the range, just keep on ignoring all the multiples. So we are good with this. 8 is already false. Just skip it. 9 is already false. Skip it. Skip it. 11. It is true. Then capture it. And then move ahead. And 12 is already false. Just skip it. So this is our Sieve of Eratosthenes. And in this case, we will be able to find all the prime number till a specific number. Let's say in this case, we were having left and right. If I am able to capture all the prime number from till right, then I can apply this formula. Firstly, I can apply this formula, and then I can ignore all the prime number less than r. And now in this approach, what will be the time complexity? See, finding all the primes till right value is going to be order of n into log of n. And the other thing is finding the pairs within this range. That will definitely be around n or less than n. So this is our final time complexity of this approach. Now let's write the code for this approach. Here first of all I will be taking a Boolean array that will work as my sieve. Okay, Boolean array, let's call it as prime. is prime. If it is true, it's prime. If it is false, it is not prime. New boolean of size. See, my num2 can go till right, so it will be right plus 1 because I want index till right. Arrays dot fill is prime. Is prime will be filled with true. Okay. Apart from that, you also need to take care of one thing, that what is the range? The range is from 1 to 10 power 6. So left can also be 1. And you should be knowing that 1 is not prime. Is prime of 1 is false. And now just take care of the starting with 2. If I just started 1, everybody will be false. I equal to 2, I less than equal to right, I plus plus. Now first thing you have to check is whether the current number is prime or not. Is prime of I. If it is prime, then consider this number. Let's not consider this number, we will consider later on while just doing one iteration from left to right. Okay, if it is prime, then what I have to do is int j is equal to I plus I, j less than equal to right, and I plus equal to I. Sorry, j plus equal to I. Okay, what does it do is, it's like a table of I. So for 2 it will be 4, 6, 8, 10 like this, and all of these values will be false. They are not prime. Is prime of j is equal to false. Now starting from 2, I'm going till the right value. If it is prime, just beat like this and make all the multiples non-prime. Now my Sieve of Eratosthenes is done, and I want to capture all the values from left to right. So I'm just going to take a list of integer primes equal to new array list. Okay, and starting from left, I equal to left, I less than equal to right, I plus plus. If is prime of I, if it is a prime number, primes dot add I. Now I have captured all the primes from left to right. Once all the primes are captured, what we want? We want the pair, adjacent pair with the minimum value. Adjacent pair with the minimum value. And for that you can do anything. What our answer will look like? Answer will look like something like this: -1, -1. If I don't have any answer, I need to take care of the diff. Diff is equal to, let's say, integer dot max value, because I want to minimize the diff. I have to iterate over these primes. Int, let's say int j is equal to primes dot size -1, j greater than 0. Okay, what I'm trying to do is I'm going to get a pair of j and j plus 1, or you can say j and j minus 1. So j will go from n minus 1 last index 1 greater than the 0 index, and in this case I definitely have to decrement j. I have decremented the j. Now you just have to check the diff between these two elements. And what is the diff? Let's say that is diff primes dot size primes dot get j minus primes dot get j minus 1. See, definitely it will be an adjacent pair, because adjacent pairs are going to give me the minimum delta. That is d. If this d is less than the already captured d, it means we have new answer. That new answer is having this new diff, and the answer is equal to new integer. What is the new answer? Primes dot get. Firstly, we have to get the minimum lesser value. Lesser value is at j minus 1 and bigger value is at j. Primes dot get j. One more thing, like if two pairs are satisfying this condition, check the pair with the smallest value of num. In this case, if d is the same, if it is also the same, just capture it, because we want the pair with the least value. And now in the end, just return this pair, return answer, and let's test over sample test cases. Sample test cases are giving me error because I removed a bracket mistakenly. Sample test cases are passed. This is my sieve, and from this sieve I only want prime number within this range. Then just capture prime number within this range, and this range is already sorted, and we want to get pair with adjacent pair, and adjacent pair I can check with order of n size loop, just one iteration. Now let's submit our sample all the test cases. It is working fine. It's working fine. I hope you understood the approach. It is sieve method. The second method is also going to work, where you can find the prime numbers in the square root of n time. Okay, thank you guys. If you have any doubt, you can comment down below. Bye bye.